Charisma, we have been developing hardware, software, and protocols to be able to harmonize Raman spectra so that we can quantitatively compare Raman spectra of a given sample with different equipments. And that is fundamental because this will allow us to implement a broader use of Raman measurements with different equipments at different locations and integrate and connect and interlink this data.
The most important result is that we are able to apply Raman spectroscopy to find the solution to many problems in different fields. In Charisma project, we have twinning different equipments, and we have demonstrated that we are able to obtain similar results with different equipments at different parts in the world.
So even if we are advancing in calibration and harmonization, there is still a lot of work to do. For example, we are testing our protocols and materials for a specific number of excitation wavelengths, and we are still testing how to optimize them. And it would be also great to see the effects of calibrating properly when Raman data are used in combination with other characterization techniques, or also in general to get some information, and this will be very relevant.
I think the most important part is going to be expanding the wavelengths and the different Raman systems that can be used. At the moment, we've gone for the majority of the people that exist, so people that use 532 and 785 nanometer lasers. If we can expand that to cover all systems that are currently available in the market, as well as better support for things like scanning systems and incorporating more bespoke techniques such as SIRS and TERS, I think that would be a fantastic route for Charisma to take.
Well, that's a nice question because the way that this result can benefit the research is, on the one hand, because we will have data that can be handled and understood not only by the person who made it, but all the metadata, all the information is associated to the experiment will be there. And at the same time, even can outreach to other people who can access this data with different kind of systems, since they will be in a format that is compatible to everybody. And you will get all the information associated to it.
One of the major problems that we have at the industrial level is the lack of reproducibility or exchange of the data between the different devices. That is a massive task that needs to be taken when you want to transfer the data from the laboratory to production. With Charisma, we're going to reduce dramatically that phase, the transition in between how to use the data. So the big approach for the industry is going to be how easy and accessible the data sharing internally will be with this product.
Regarding the benefits, in this case, in the case of encapsulate solution, we reduce the waste, the food waste. Moreover, it's possible to identify new particles inside of the packaging that could present risks for health. And also, you have to take into account that Raman spectroscopy gives us another information, like the agglomeration stage of the particles. And this is very useful for catalysis or for paint industry, for instance.
One of the more important factors in industry is making sure that you can transfer a model from a laboratory to the process line, and being able to characterize fully your instrument's behavior and understanding the differences between your high-end lab-based system and your lower-end process line system is extremely important, and the Charisma protocol allows assistance in being able to transfer data from one to the other.
But almost anywhere. In the end, Charisma is about Raman spectroscopy, and Raman spectroscopy is basically about characterizing whatever material, a product, a process, so you can validate something, you can monitor the state of a given application, you can do many things, and in all these cases, what you need is something that can be with a result-based transfer, that a given spectrum, given information that you read here, can be read and validated somewhere else. So applications is basically limited by imagination.
I think that the most important one is going to be the academic people by itself. So the capability to have reproducible results and data that can be reproducible and shared across the Raman community. In other industry, for example, in the Raman School, the event that we have hosted, it is clear that there is a need for many areas to have a way to produce the data and to share the data. I think practically everybody that is in the Raman community and requires to share data and have consistency of the data will be a benefit.